Now to explain how to measure the oscillation frequency for a crystal unit. Oscillating frequency refers to the actual frequency of the oscillation circuit when the crystal is implemented. The oscillation frequency is mainly determined by the characteristics of the crystal unit, but the characteristics of the microcomputer, external load capacitance, and stray capacitance of the PCB must be taken into consideration to determine the actual oscillation frequency. If you directly touch the oscillation circuit with a probe, the oscillation frequency cannot be measured accurately, so non-contact measurement is important. When measuring the oscillation frequency, measure directly with a spectrum analyzer or a frequency counter. When using a spectrum analyzer, pick up the signal of the oscillation circuit with a non-contact antenna and read the peak frequency of the observed value that appears on the screen. Even when using a frequency counter, you will be probing without contact. In many cases, signal amplification is required to acquire a measurable level, and it is necessary to prepare an amplification circuit. You can also use an oscilloscope as an amplifier circuit and measure the output signal from the oscilloscope with a frequency counter. Note that the frequency that appears on the screen of the oscilloscope often has low measurement accuracy. We measure the oscillation frequency using a spectrum analyzer for reference. There is a difference in oscillation frequency between the customer's board and our test circuit, even if the same crystal unit is used. This is called oscillation frequency correlation. The actual oscillation frequency is affected by the characteristics of the amplifier circuit, external load capacitance, and stray capacitance of the mounting board. The frequency measured on the mounting board may differ from the frequency measured on our test circuit. This correlation difference depends on the condition of the board and must be confirmed when evaluating the circuit. If there is a large frequency correlation and the actual oscillation frequency exceeds the expected value range, it may lead to a malfunction on the customer's board. Here are some examples based on previous slides. The crystal is within the tolerance of plus minus 20 ppm, centered on 25 MHz for our test circuit. If the correlation difference between our test circuit and the customer's board is plus 5 ppm as shown in the figure, the center 25 MHz has a frequency tolerance shifted 5 ppm to the plus side. This may exceed the specified value of the customer's request. When high frequency accuracy is required, it is necessary to confirm this deviation. When checking the oscillation frequency, be sure to check that the frequency correlation can be adjusted within the desired frequency range by adding this frequency correlation to the product specifications. For customers, the frequency correlation can be implemented by mounting a crystal with a previously known frequency on the board. The customer can then confirm by measuring the comparing and oscillation frequencies. Murata can provide samples with individual frequency data if needed. Please reach out to your local Murata representative for more information. If you have any questions or concerns about oscillation frequency correlation, please contact Murata. Thank you for watching.